Okay, let's dive into this explainer. If you're building automated workflows, you know the drill. You've almost certainly hit that wall trying to interact with a form or a login that's locked down by a CAPTCHA. So today, we're tackling the very specific challenge of solving CAPTCHAs right from a Vercel Edge Runtime function. Our goal here is to skip the fluff and help you build production-grade, automated CAPTCHA workflows that can actually hold their own out in the wild.
We've got a pretty highly structured journey ahead of us. We're going to cover the production reality, the core workflow, an operational checklist, how to avoid common traps, a quick FAQ, and we'll wrap up with building production-grade infrastructure. Let's get to it.
Section 1. The production reality, or moving beyond the happy path.
So, we need to acknowledge a universal developer pain point here. You write a script, and it works flawlessly, right? You run a quick 5-minute happy path test on your local machine, and it's golden. But then you push it to an unattended production environment. We're talking CI pipelines, internal queues, cron jobs, worker pools, and it just completely breaks down. Suddenly, your simple script has to survive deploy windows, random network hiccups, and entirely unannounced changes to the CAPTCHA family on the target page. It's a whole different ballgame.
Quick safety note before we get into the actual code logic, because we need to establish a really important boundary. This isn't just a standard disclaimer, it's actually a foundational requirement of professional engineering. This type of workflow should strictly be used in applications you own, environments you operate for an authorized client, or situations where you have a permitted contractual data collection agreement. Professional automation is all about building predictable systems, not circumventing protections without authorization. Okay, moving on.
Section 2. The core workflow, the lifecycle of a CAPTCHA solve. To actually survive in production, the mechanics of our solve lifecycle just need to be rock solid. We need predictable solve latency and clean failure modes. Here are the 5 fundamental steps. You capture the exact inputs, submit the task, poll for the result, apply the token in the exact same session, and then verify downstream acceptance. Now, what's really interesting about this slide is step 2. If you treat any failed API response as a real error right at submission, you prevent those massive cascading failures later on in your script. It's a lifesaver.
Section 3. The operational checklist. Building for reliability. All right, to guarantee reliability in that Vercel Edge Runtime environment, we've got to start with our request rules. You absolutely must capture only the exact parameters the live challenge expects. I'm talking site key, page URL, action, method, and maybe an optional proxy. Because if you start sending extra parameters, you're going to create false debugging paths that will literally just waste your team's time later. Oh, and a massive golden rule here. Log useful failure details for sure, but never, ever expose your API secrets or raw tokens in those logs.
Next up, we have polling and state rules. Controlled polling is non-negotiable. A really solid baseline is to wait 15 seconds before your first poll, then poll every 5 seconds up to a hard timeout of, say, 120 seconds. Because look, overpolling just adds noise, but underpolling slows your whole workflow down. You also have to cap your retries. I suggest capping at 3 attempts with exponential backoff. If you don't, you risk hitting those infinite retry loops that will just silently drain your cloud budget over May.
Now, let's talk numbers. These are the crucial developer metrics you need to be watching. Notice how we track first solve latency and solver success rate completely separately from end-to-end downstream acceptance. This is a real game changer. Think about it. If a failure happens, you need to know instantly. Did the solver fail, or did your downstream workflow just reject a perfectly good token? If you aren't measuring these distinctly, you basically can't defend the stability of your integration.
Section 4. Avoiding common traps. What actually breaks unattended workflows? Let's look at the specific pitfalls that cause those retry storms and burn through budgets. A critical error developers make is treating their very first successful local test as quote-unquote production ready. They might guess the CAPTCHA inputs or just poll without any limits. And what happens? Well, they end up in wrong parameter loops or they get hit with massive infinite polling bills. Measuring only solver success while completely ignoring downstream acceptance, that'll blind you to systemic workflow failures right when you need to see them most. And there's more. Retrying every single failure blindly is a massive trap. Infinite retries just hide the real defects in your code, while again, rapidly burning your balance. Another super frequent mistake is applying the solve token in the wrong session, which actually is a perfect transition into our edge cases. Section 5. Frequently asked questions. Troubleshooting the edge cases.
So here is absolutely the most common post-solve question, the one that causes developers to literally pull their hair out. Why can a perfectly solved token still be rejected by the target site?
The answer? Almost always, it's mismatched sessions. If you trigger a challenge in one browser context or HTTP client and then try to apply that solved token using a completely different cookie jar or a different IP context or a different logical session, it is going to fail. You absolutely have to apply the token in the exact same session that triggered it, no exceptions.
Next question we get all the time. How can developers actually eliminate those late-night page roulettes and keep the workflow stable when no one is watching? Well, the secret is observability. You have to wire specific KPIs into your existing dashboards. Monitor your first solve latency, your P95 latency, and your solver success rate right out of the gate. And crucially, set up alerts that trigger if there's a gap between a successful solve and downstream acceptance. You combine that with a hard cap of 3 retries using exponential backoff, and you're going to maintain a really highly stable system. Finally, the inevitable scenario. What happens when the target environment suddenly changes its protection mechanisms, and how will that impact your operating costs? The good news here is that your submit and pull loop remains exactly the same. You simply need to build your code so the method or task type is easy to update. Now, as for costs, volume scales linearly with successful solves, but I'll warn you again, uncapped retries and wrong parameter loops are your real cost killers. They increase costs exponentially, so keep those limits tight. Section 6, Production-Grade Infrastructure, the final takeaway. So the crucial point is this. A reliable automation script isn't an accident. It demands exact inputs, heavily controlled polling, a strict same-session handoff, capped retries, safe logging, rigorous monitoring, and strict tracking of downstream acceptance. If you skip any of these, your workflow is going to be fragile. If you take one thing away from this explainer, let it be this. A Vercel Edge Runtime capture workflow must be treated with the exact same respect as your core production infrastructure. It is not a happy path demo. It requires real engineering discipline. I'm going to leave you to think about your own code with this final question. Are your automated workflows actually built to survive the chaos of unattended production? Or are they just sitting there, waiting for the next retry storm to bring them down? Go review your code against this operational checklist and build workflows that actually last. Thanks for joining me on this explainer, and happy building.